When I say Idaho, what's a few words that comes to your mind? Mountains, forests, beautiful, outdoors. For a few, I would assume you said potatoes, and that'd be warranted because Idaho produces the most potatoes in the United States, and it's not even close. But where in the state are these potatoes produced, and why? Well, first off, Idaho sits in the northwest corner of the United States, covering a total area of just over 83,500 square miles. 82,600 of that is land area, making it the 11th largest state in terms of land area, but the 14th largest state in terms of total area. Due to Idaho being a pretty decent sized state, the landscape is really diverse, with the north being covered in dense forests, central Idaho being covered with rugged mountains, and the Snake River Plain to the south, which is where the jackpot lies. The climate, along with the landscape, is perfect for potato production, but why? The answer lies deep beneath Earth's crust in the state of Wyoming. If you're thinking Yellowstone National Park, you would be correct. But this video today is not going to be about Yellowstone National Park setting in the state of Wyoming, but its destructive path on its way to where it is today. Yellowstone is one of the most well-known places in the world, from its hot springs to its geysers, from its wildlife to so much more. But its history and its path to where it is today is not well known. In the mid-1970s, landmark scientific studies suggested the existence of hotspots like Yellowstone, which is what generates the park's geysers and hot springs. These hotspots are powered by a plume of hot, but not molten material that is believed to be as deep as the boundary between the Earth's mantle and the Earth's core. Now, when that hot material rises, it melts, turning into magma, which goes into the magma chambers that lie beneath Yellowstone. Today, the Yellowstone hotspot sits in the state of Wyoming, but it wasn't always like that. See, the hotspot itself is stationary, but the North American plate above it is not. The plate moves at about 1 inch per year to the southwest, meaning that the Yellowstone hotspot spent a good duration of its life in the state of Idaho. The origin of the Yellowstone hotspot is largely unknown, but growing evidence suggests that the hotspot started out in the Pacific Ocean over 40 million years ago. For many years, it was suggested that the Columbia River basalt was the origin in eastern Washington, eastern Oregon, and western Idaho, but as time moves on, evidence of lava have been found in the coastal mountains of Oregon and Washington, telling a story of an ancient eruption. This is called celotia, and it has chemical and physical characteristics that suggest that it formed from a mantle plume, which is what's also underneath the Yellowstone hotspot. It also has composition that's similar to the Columbia River basalts, which could indicate that these eruptions are related. The hotspot has produced some of the world's largest eruptions on its path to where it is today, creating ancient calderas, which is large volcanic craters that form after an eruption that can cause the mouth of the volcano to collapse in. Scientists have dug 6,000 feet and still can't find the bottom of the eruptive flow, showing how massive and truly devastating these eruptions have been. Now, if you drive through southern Idaho and you're driving through the plain, you can't see these calderas, and that's because years of volcanic flows and sediments have filled the low-lying plain, and which is why you can't see the calderas today. One of these eruptions happened about 8.1 million years ago, called the Castle Fork Crossing. Mapping shows that the outflow covered over 8,000 cubic square miles and went as deep as 4,000 feet. Now, based on these calculations, on the VEI scale, this eruption was an 8.6. To just show you how truly massive this is, Mount St. Helens was a 5, and then the last Yellowstone eruption is believed to be an 8. Now, obviously, years of lava laying in the low-lying plain has created a really fertile landscape for the state of Idaho, which has made it perfect for agriculture. But what else has the Yellowstone hotspot left behind that can't be seen? The answer to that is the Snake River Plain aquifer, which is basically one massive underground sponge. This sponge acts as a natural water source for much of southern Idaho and is a major contributor to Idaho being the highest usage of water per capita in the United States. Snowmelt from the surrounding mountains seeps into the sponge below, taking the water about 200 to 300 years to travel west until it's dumped out from various springs that is protected by various parks in the Thousand Springs State Park system. Now, the curious mind might wonder, how do we know this is the case for the Snake River Plain? Well, there is plenty of evidence suggesting this just by looking at the landscape or digging deep below. Boreholes have been drilled into the plain in which volcanic rocks, specifically rhyolite rocks, were found, confirming these underground volcanic calderas. When you look at the physical landscape today, you can actually see the evidence right in front of you, with volcanic domes and cones dotted throughout the region, with the Big Southern Butte, which is one of the largest in the world, and the Twin Menace Buttes, which is among the largest tuff cones in the world. There is also dark lava fields that spill out throughout the region, with the Wappi lava field to the east, Hell's Half Acre to the south, and then most notably Craters of the Moon National Monument and Preserve, which is the largest out of all of these. Idaho has been among the fastest growing states in the country for decades now, and the Snake River Plain is one of the main reasons why. The majority of the state's population lives here, along with much of the state's economic output coming from this region. Not to mention the capital city of Boise is also located here, showing how important the Snake River Plain truly is. I find it interesting that something so destructive and so powerful can be so beneficial for this state. Clearly, the physical geography has been a blessing for Idaho in so many ways, providing a great natural fertile land for agriculture, along with the underground aquifer, creating a natural water source which has magnified the importance of southern Idaho. You add all these together and you create a perfect environment to settle and survive.